Okay, we're back. We're going to look at number 20, 21, 22, 23, and 24 from the exam. Number 20 is dealing with circles, and we're going to have a unit on circles here in a couple of weeks, so I'm not going to go too far into this. However, I do want to read it. I'll read the question, and then you guys can write down this vocabulary, which maybe you wrote down before already, but the more you write it down, the better. And since this is extra credit, if you want to get the credit, you need to write it down. All right, so it says in circle O, shown below, diameter AC. I didn't even have you write down what diameter is, but hopefully you remember that that's AC, that's this line right here, is perpendicular to CD. So that means that these two lines are perpendicular to one another, which means that they create 90-degree angles or right angles at point C. And chords AB, BC, AE, and CE are drawn. And we have the definition for what a chord of a circle is. It is a straight line segment whose endpoints both lie on the circle. So as you can see, BC here is a chord because both endpoints lie on the circle. All right, and our answer is going to, well, let's look at the answer choices. And also, pay attention to the fact that it says, is not always true. A lot of times they'll ask questions and say, what's not always true? Which means that the other answers are always true. And in this case, our answer is 1. Angle ACB is not always going to be equal to or congruent to BCD. So that's here. ACB is not always equal to BCD. Right, so that's the answer there. Hopefully, we're going to go over this in a couple weeks, so we'll get into it a lot more, but that's what I want you to write down here. Okay, let's look at number 21. It says that in the diagram below, triangle ABC is similar to triangle DEC. So remember, this little symbol means similar. I want you to write down here what it means for two triangles to be similar. In this particular problem, this is what you're going to need to know. Because down here it says if AC is equal to 12, DC is equal to 7, and DE is equal to 5, and the perimeter of ABC is 30, so that means ABC, that means all the way around is 30. So perimeter equals 30. What is the perimeter of DEC? So we're looking for this perimeter over here of the smaller triangle. So in this case, you know the perimeter of ABC is 30. You don't know all the sides, but you do know it is 30. For DEC, you don't know, you know one extra side, but you don't know the perimeter. Now, it's important to understand this part down here. If two triangles are similar to one another, the ratio of the perimeters is the same as the ratio of the sides. Okay, so now looking at what it says, triangle ABC and is similar to DEC. That means AB is corresponding to DE. Be careful. That means DE over here is corresponding to AB. All right, then we know that BC is corresponding to EC. So that means BC and EC, and that means that A and C, these two, is corresponding to DC. All right, you have to use AC and DC because you have those two corresponding sides. So you can set it up like this. 7 over 12 is equal to X over 30. What that's saying is the perimeter of I'm sorry, the ratio of the side in the smaller triangle, 7, to the side in the larger triangle, or the corresponding side in the larger triangle, which is 12, is equal to, or the same ratio as, the perimeter of the smaller triangle, which we don't know, to the perimeter of the larger triangle, which is 30. All right, once you set that up, you're all good. So we can cross multiply, and you end up with 12x is equal to 210. Then divide by 12, divide by 12. Let me get my calculator here. Divide that out. So 210 divided by 12 is 17.5. Now, don't do this. This is what a lot of students would do. They would do 5 over 12. You can't do 5 over 12 because 5 and 12 are not corresponding sides. So you cannot do that. You have to use 7 and 12. All right? So there we go. That is number 21. All right, on number 22, a couple things I want you to write down. At the top, when a line is dilated, the slope does not change. That's going to help us answer this question. Also, down here, a couple more properties about dilations. Angle measures remain the same. Parallelism. That means everything, all the lines that are parallel are going to remain parallel. Collinearity. That means points remain on the same lines. Orientation means the lettering remains, or the order remains the same. All right, so let's go back up to this part here. When a line is dilated, the slope does not change. So we start with this original line. The line 3y is equal to negative 2x plus 8. And it says that is transformed by a dilation centered at the origin. Which linear equation could be its image? Right, so what we need to do first is find the slope of the original line. So go ahead and find the slope of this if you know how. All right, and come back. I'll be back in a second. All right, let's go ahead. Hopefully you tried it, but let's go ahead and do it. I'm going to write it down here. 3x is equal to negative 2x plus 8. We're going to get this into y is equal to mx plus b form. And remember, this is the slope. So all we need to do here is divide everything by 3. And you end up with y is equal to negative 2/3 x plus 8 over 3. And our slope is this. So the slope of our line here, or our m, is equal to negative 2 over 3. What we need to do now is go through all the answers and see which one comes up with a slope of negative 2 over 3. Okay. So, let's look at number 1. So I'm going to look at number 1. I'm going to write it down over here. So I'm going to look at this one. So I'm going to have 2x plus 3y is equal to 5. Now we need to get y by itself and put in y equals mx plus b form. So what you're going to do is move this 2x over here, minus 2x. So we have 3y is equal to, now I'm going to put this in front, so I'm going to have negative 2x plus 5, all right? And then I just divide by 3, divide by 3, divide by 3, and we get y is equal to negative 2/3 x plus 5 over 3. Well, it looks like we have our equation that gives us the same slope. So it looks like our answer is number 1. But let's look at number 2 and just check to see what the slope is there. And it's good for a little practice. So I want you to write this down. So now I'm looking at number 2 just to check. So we have 2x minus 3y is equal to 5. Again, I want to put this in y equals mx plus b form. So I'm going to subtract 2x again, subtract 2x again. We end up with negative 3y is equal to negative 2x plus 5. Then we divide by -3, divide by -3, divide by -3, by everything. And we end up with y is equal to, now you have a negative and a negative right here. So that makes that positive 2/3 x. And then we have a positive and a negative. So it's really going to be -5/3. And that is definitely not the same slope because one is positive and one is negative. So I'm not going to do the other two, but we know our answer is number 1 because it has the same slope. All right, let's look at number 23. It says a circle with a radius of 5 was divided into 24 congruent sectors. The sectors were then rearranged as shown in the diagram below. And it says now to the nearest integer, the value of x is, and we have 4 choices. Okay, so let's talk about what we know. We know the radius is 5 of this original circle. So we have this radius of 5. We could find the area and the circumference. So let's find both the area and the circumference of this original circle. So we have area is equal to, remember, pi r squared, so that's going to be pi times 5 squared, and that's going to be equal to 25 pi, which is approximately 78.54. I don't know if I'll even need that, but, you know, just write it down. Remember our circumference, one of the formulas is pi times d, which is equal to, remember d is the diameter, which our diameter is 10, so it's really going to be 10 pi. And so that's going to be approximately 31.42. Now, I'm not sure if I'm going to have to use either one of those or both of those. So, let's see. All right. So, when we're looking at this, look at what they do with the circle. They cut it into pieces, and then by the end we have what you almost could call a rectangle, or pretty close. Now, what is the length of each one of these pieces? If, like, I'm talking like this length right here. Think about that. What is the length of that? Well, if you think about the fact that these pieces were all cut, they were equal congruent sectors, this side must be 5. So these pieces all must be 5. So like this piece right here, that's 5, right? Now, at this point, you need to think about what's going to be important. And there might be many ways to do this, but I'm going to use the area that we found. So I'm not going to focus on the circumference. I'm going to use the area. Now, if you take a circle, and we know the area of the circle to be about 78.54 or 25 pi, if you rearrange it, cut it up and rearrange it, the area of this figure has to be the same because you're just taking the circle and rearranging it. You're not adding or subtracting anything. So the area of this should be just about the same, which is basically a rectangle. So you basically have a rectangle, but we want to know what x is. Well, if we know one side is 5, we know the area of a rectangle is length times width. If we know the 5, we have to think to ourselves, 5 times what will give me this 78.54? Well, it's a good thing it's multiple choice, so we can just say, well, 5 times what? Well, will 5 times 31 give me 78.54? No. And hopefully you can figure that out pretty quick. So that's not right. Well, what about 16? So 5 times 16. Well, I don't know if it's going to give you exactly 78.54, but it's going to be closer than any of these others. And That's going to be our answer. The other ones aren't even close. 5 times 31 is, 155, I believe, off the top of my head. 5 times 12 is 60. That's not close. 5 times 10 is 50. So the only one that's going to get us close to the area that we had of the original circle is going to be that value of 16. So that is our answer, number 2. Okay, looking at number 24, the last multiple choice question, I believe. It said, which statement is sufficient evidence that triangle DEF is congruent to ABC? So let's look at our answers, potential answers. AB is equal to DE. So AB and DE. And BC is equal to EF. Well, if you remember going back to congruence, or when we talked about it, how do you prove two triangles congruent? You need more than just two sides. Maybe if we had an angle, like if we knew that this angle was equal, that'd be different. But we don't know that. So this is, they just give us two sides being equal. So that doesn't prove anything, because you could have two sides, being equal, but we don't know how big the angle is. So you could have two sides being equal, but have it like that. So we don't know. This doesn't show us anything, number one. That doesn't prove that two triangles are congruent. All right? That does not prove it. Okay, what about angle D is congruent to angle A, and angle B is congruent to angle E, and angle C is congruent to angle F? Well, if you remember, one of the things we talked about that does not prove two triangles congruent is angle, angle, angle. Angle, angle, angle does not prove triangles congruent. Now, it does show that triangles are similar, but you can draw two triangles that have the same angles but are not congruent. And I'm not going to go into any big example, but I could draw this triangle and this triangle, and they could have the same angles but not be congruent. So just remember, angle, angle, angle does not prove two triangles congruent. Now what about number 3? There's a sequence of rigid motions that map AB onto DE. So let's erase this now. So that maps AB onto DE, that maps BC onto EF, and maps AC onto DF. All right. If that is the case, then these two triangles must be congruent. So if you could do it, this would be sufficient evidence that those two triangles are congruent. All right?